This is Algebra 2, Lesson 5 dividing polynomials. So we're going to talk today a little bit about long division in general and then how to use long division to help us divide polynomials. Our goal is that you will be able to divide polynomials using long division. That's the first half. And then the second half, which we'll get to, is that students will be able to divide polynomials using synthetic division. So first off, you can divide polynomials using steps that are similar to the long division steps. When you try to factor a polynomial, what you are trying to find is a divisor of the polynomial that gives a quotient, the other factor, and a remainder of 0. This suggests that being able to divide one polynomial by another could help you factor polynomials. Numerical long division and polynomial long division are very similar. So we're going to start with just doing some review of numerical long division. So when we write this, we're going to take our dividend 672 and our divisor 21, and we're going to write them like that. The 672 underneath and the 21 outside. Now the first thing you look at is, can 21 go into 6? And it can't, so you put a 0 above it. Can 21 go into 67? That is what you want to look at, and in fact it can 3 times. We go 3 times 21 and we get 63, and we subtract, we get 42. Now I go, well, how many times can 21 go into 42? It can go in 2 times. We put that to the right of our 3 we already put up there. 2 times 21 is then in fact 42. We subtract and we get 0. That implies then that 672 divided by 21 is 32. Okay, so polynomial long division is similar. We're going to use polynomial long division to divide 6x squared plus 7x plus 2 by 2x plus 1. So 6x squared plus 7x plus 2, that's our dividend, that goes underneath. 6x squared plus 7x plus 2, and 2x plus 1 is our divisor, that goes outside. Now when we do this, notice that 2x plus 1 is 2 terms. 2 terms cannot go into 1 term. So when we say, can 2x plus 1 go into 6x squared, it's not possible. 2 terms can't go into 1. But what we can look at, in fact, is, can 2x plus 1 go into 6x squared plus 7x? And it can. What you want to do, though, is we multiply by how many times it goes in. Well, that's looking at what do I multiply a 2x by to get a 6x? Well, 2 times 3 will get you 6, and x times x will get you x squared, and it's a positive 2 and a positive 6, so it's a positive 3x. So now we're going to take both the terms in 2x plus 1 and multiply them by 3x. When we do that, we're going to line it up perfectly underneath the 6x squared plus 7x in our dividend. So 2x times 3x is 6x squared. And 1 times 3x is 3x. And it's a positive. Now we're subtracting, and so you got to think about, we're subtracting this whole thing. So what you want to make sure you do is that you distribute that negative to both parts. So I always turn it into a positive on the outside, and then I distribute the negative through, because 6x squared minus 6x squared is 0, and 7x minus 3x gives us a positive 4x. Now we bring down the 2. Positive 2, and we have 0 plus 4x plus 2, but you know that 0 plus is just 0, so we can just get rid of that, and we have 4x plus 2. Now we want to look at, well, how many times can 2x plus 1 go into 4x plus 2? Once again, we're going to look at the 2x and the 4x, the leading terms, and then figure out, what do I multiply 2x to get a 4x by? I multiply by 2, so I'm going to go 2x, I'm going to multiply by 2 up there, so I then distribute that through. 2x times 2x gives me 4x, and 2 times 1 gives me 2. But remember, we're subtracting this, so you want to distribute that negative through, and when you do, you can see that you end up with 0. If you end up with 0, that's good. You want to end up with 0, because if you end up with 0, it means that 2x plus 1 is a factor of 6x squared plus 7x plus 2. So we can say 2x plus 1 is a factor of 6x squared plus 7x plus 2. What this means is that our 2x plus 1, our divisor, and our result, our quotient, 3x plus 2, if you were to write them out like that and FOIL, you're going to end up with 6x squared plus 7x plus 2. Are you practicing lines or do you need to come in here for some reason? Okay, that's what I guess. No, you're fine. Sorry about that, guys. Okay, so we have this this concept that says if you end up with if you are dividing and you end up with, so you've got your divisor, your quotient, and you have your remainder. If your remainder is 0, then your original polynomial equals your divisor times your quotient. And then your divisor and your quotient are both factors of the original polynomial that we started with. Okay? There's a few key things you need to know about to use this long division. To use it, your polynomials have to be in standard form with 0 coefficients where appropriate. So that means if you have something like x cubed plus 2, when you write that out, you have to write it out as x cubed plus 0x squared plus 0x plus 2, or it's not going to work correctly. Okay? The other thing you have to pay attention to is that the process of long division, it stops when the degree of the remainder is less than the degree of the divisor. Okay? So then the process stops. So I want you guys to try and do these next ones on your own. I'll help you get it set up, and then I want you to pause the video and try it on your own. So we're dividing 4x squared plus 23x minus 16 by x plus 5. So our dividend is 4x squared plus 23x minus 16, and it is being divided by x plus 5. Okay? I'm going to get you started on the first step real fast here. X plus 5 is 2 terms. 2 terms cannot go into one term 4x squared, so there's a 0 that goes there. However, x plus 5 can go into 4x squared plus 23x. You look at what do I multiply x by to get 4x squared? Well, you're going to multiply it by a positive 4x. So then we do that. 4x times x is 4x squared. 4x times 5 is a positive 20x. Now don't forget to, when you subtract, distribute that negative through. That's the biggest mistake that kids make. Distribute it through, and we get 0 plus 3x. Okay, pause the video here and see if you can finish this problem on your own. All right, you just watched my solution. I didn't narrate as I went, but you could see my thought process through. I ended up with negative 31. Now notice I stopped because negative 31 has a lower degree than x plus 5, which means that's my remainder. So when you write your answer, it says what is the quotient and the remainder? Your quotient is your result on top. That's your 4x plus 3. And your remainder is this negative 31 that we ended up with. Okay. Now, I want you to actually set up this next one completely on your own. I'm going to pause the video and see what you guys can do with it. All right, you can see my solution. I got my quotient to be 3x minus 8 and my remainder to be 0. So why do we do this polynomial long division? Well, we do this to check if something is a factor of another polynomial. So let's take a look at this next one. It says checking factors. Is x squared plus 1 a factor of 3x to the fourth minus 4x cubed plus 12x squared plus 5? What we're going to do is really ask, is 3x to the fourth minus 4x to the third plus 12x squared plus 5 divisible by x squared plus 1? So we're going to set up our polynomial long division. Now, if you write that underneath your divide by sign, you're actually making a mistake. And the mistake is you haven't accounted for x of every degree. You have an x to the fourth, an x to the third, an x to the second, and 5 is technically x to the 0, which means you're missing an x to the first. So you do, in fact, need to have a positive 0x in there to account for it. It has to do with place value. If you're missing that, your division is going to get very confusing. So we're going to divide all of that by x squared plus 1. Now you might notice x squared plus 1 is missing an x. So it's x squared plus 0x plus 1. Now we're ready to do our polynomial long division. Once again, when we do that, 3 terms can't go into 1 term. They can't go into 2 terms, but they can go into 3 terms, and you keep working from there. Pause the video from here and see what you can do. All right, if you get to this point, in our quotient we have 3x squared minus 4x plus 9, and in our remainder we have 4x minus 4. I stopped at this point because the degree of our remainder, 4x minus 4, is less than the degree of our divisor, x squared plus 0x plus 1, which means there's no way I can get x squared plus 0x plus 1 to go into 4x minus 4. So if you end up with something like this, where you do have a remainder that is not 0, even if it is a constant or anything, if it's not 0, then that means that in fact, what you're checking is not a factor. So we would say that x squared plus 1 is not a factor of 3x to the fourth minus 4x to the third plus 12x squared plus 5 because the remainder is not 0. We've got one more problem to do in our notes. After this, that's this next one down here, is x minus 2 a factor if p of x equals x to the fifth minus 32? If it is, write it as a product of 2 factors. What I want you to do first is I just want you to pause the video and try to set this up correctly and check your setup with mine, and then you'll pause it again. This is what your setup should have been. X to the fifth plus 0x plus 4 plus 0x to the third plus 0x squared plus 0x minus 32 divisible by x minus 2. Because you need to account for every single power between x to the fifth and negative 32. All right, pause the video now and try the long division on your own. All right, that was a lot of work. But if you did all your work correctly, you can check it all with mine. You should have ended up with a remainder of 0. All right, you can see my work up top, what I ended up with on top. X to the fourth plus 2x to the third plus 4x squared minus 18x plus 16. And then I ended up with a 0 plus 0 for my remainders. So it says if x minus 2 is a factor, right, p of x is a product of the 2 factors. So x minus 2, yes, it is in fact a factor. So we're going to say x minus 2 times the quotient or the result of our division problem. That's what's all the way up at the top. All right, so it's x minus 2 times x to the fourth plus 2x cubed plus 4x squared minus 18x plus, no, that's an 8, not an 18. We have 4x squared plus 8x plus 16, close your parentheses. If you wanted to write x to the fifth minus 32 another way, you can write it as x minus 2 times the quantity x to the fourth plus 2x to the third plus 4x squared plus 8x plus 16. All right, and so that is our long division notes for today. This is the end of lesson 5.4a, dividing polynomials using long division.